Okay, then in AS we move on to independent events. Independent events are events that have no direct impact on each other. So if one thing happens, it doesn't change the probability in any way of the other event occurring. This in GCSE we call the AND rule. So the probability of A and B, when we got independent events, will be the probability of A multiplied by the probability of B. And that's in red, so that's a formula that you won't be provided with. And in the next example, which leads then onto the sort of AS questions you'd be expected to deal with, we're going to be combining these laws for independent, mutually exclusive, and the general rule. So events A and B are such that the probability of A occurring is 0.3, the probability of B occurring is 0.2, and the probability of A or B occurring is 0.44. Show that A and B are independent. So what we need to do here, we know that if they're independent, we can apply that rule. But if it doesn't tell us they're independent, we can't rely on that rule alone to figure out whether or not they are. But because we have this rule as well, okay, and I've got everything I need to plug into that and work out what the probability of A and B are. So the probability of A union is the probability of A plus the probability of B minus the chances of A and B occurring. So if we rearrange that, we get A and B is 0.5 less 0.44, which is 0.06. So using the addition law, which I already forgot what the proper name is, the generalized addition law, in using that, the intersection would be that. Now, also, if they're independent, then the intersection would be the product of the two probabilities. So probability of A intersection B is 0.3 multiplied by 0.2, which is 0.06. So these are consistent. Therefore, events are independent. If those worked out to be different numbers, then the events wouldn't be independent. So that's part A. Part B. Calculate the probability of exactly one of the two events occurring. Now, we've got enough information there to actually put this onto a Venn diagram. And from the Venn diagram, it's easier to figure out what they're asking there. So I've got event A, event B, the universal set. For probability, the universal set is 1. Everything inside there must add up to 1. I know that the probability of the intersection now is 0.06. So I know that that in there is 0.06. I know A in its entirety is 0.3. So this part here, only A, would be 0.3 less 0.06, which is 0.24. I know that all of B probability is 0.2. That part is 0.06, so that's 0.14. Now, the probability of exactly one of those two events occurring will be this region, that's A occurring, or that region, which is the chances of only B occurring. So the chances of only A or only B occurring would be 0.38.